Good old spurious correlations. This one clearly is. In fact, it's from the website Spurious Correlations. I hope you had a look at it. Nevertheless, it is a correlation. The number of printing press operators in Rhode Island plotted along here, it does really genuinely seem to correlate. The greater the number of printing press operators, the greater the amount of rainfall in San Francisco. In fact, this R value here shows that it's pretty high. If you square that value, that tells you what percentage of the variation on the x-axis explains the variation on the y-axis. And the p-value of 0.01 says that there's only a 1% chance that this is a spurious correlation. Of course, if you look at enough correlations, then you're going to find, 1 in 100. If you do 1,000 different comparisons, you're going to find that, approximately 10 of them give you a p-value of less than 0.01. But you've probably heard, and I hope that you have, that a correlation is not causation. And often people can get confused and think that if two things correlate really closely, that the first one causes the second one. So that's not true. What do we need? What are the criteria that we need to establish causation? Well, first of all, we need a correlation, and we need to be a reasonable correlation. So in science, we need a decent sample size for that. Our data needs to be reasonably reliable. If it's a random number generator, then that's we're just definitely going to find spurious correlations. So first of all, we need a correlation. The second thing we need to do is establish that A comes before B. That's kind of a basic thing about the world that we live in, cause and effect, that the cause comes before the effect. So it's called temporal precedence. You've got to show that the cause actually happens and then the effect follows. Then we need to rule out all of those other things that might explain it. So if we looked at the number of drowning deaths versus the amount of ice cream sold, you'll find that that's another spurious correlation. But there's probably a confounding factor there, that on hot sunny days, more people buy ice cream. On hot sunny days, more people go to the beach and go swimming. And so it's more likely that there's going to be, sadly, more injuries by drowning. So that's the confounding factor, the other factor that actually explains it. It's not ice cream is not causing drowning deaths at sea. And that really goes to the validity of the experiment. That's why we have control variables. That's why we set up a controlled experiment if and where we can. And we do it really well. We design our experiment to be valid, to make sure that we are measuring what we think we're measuring and we're not measuring some other confounding factor along the way. And the last criteria is we need to establish some kind of credible mechanism. How is it that A could cause B? And for decades, the tobacco companies fought back hard against the medical scientists who were showing that smoking causes cancer, and they said, but you haven't showed a credible mechanism yet. And eventually, of course, when we understood more about cell biology, we were able to show the mechanism by which smoking causes cancer. So those 4 steps: correlation, we need to show that A comes before B, that we've ruled out confounding factors and bias involved in our experiment, and that we are able to present a credible mechanism. And at that point, you can then say that your correlation is a causation.